Hey, Mr. Sams, I heard you had an incident yesterday here at the high school.
I don't know what you're talking about.
See, I was in Denver. I was at this thing, and I'm getting texts that the school got evacuated because a chemistry teacher did something. Would that have been you?
I'm not real sure what you're talking about.
Well, word has it. Unfortunately, I caught him on tape. I have a student who caught the event on tape, and so I think we should watch that video. What do you think?
Sure.
Okay, so let's watch the video and see what Mr. Sams did at the high school yesterday.
This is glycerin and potassium permanganate. They sit there for a while and then catch fire. Or maybe just smoke. Yes, sir. What? Yeah!
Yeah.
Oh.
It doesn't work unless the lid's down.
Nope.
Do it again.
I liked it.
What was that?
Gotcha.
Yeah.
That was cool. I mean,
It was really cool.
it was kind of cool, actually. I mean, it's a cool experiment. Actually, there was a malfunction, I understand. I talked with the authorities today, and they said there was a malfunction of our fume hood. So
Yes.
it wasn't totally Mr.
Actually,
Sams'
you know what?
fault.
You know what the final word was on that? The fan was spinning backwards. It was actually blowing air into the fume hood instead of sucking it out.
That is a problem.
It has since been repaired.
Yes, well, reparation is a very good thing.
Yes.
Okay, so it isn't totally his fault, but it is a cool video.
Yeah.
And in fact, today, as we talk about percent composition, we want to use that to help us understand percent or ton.
Understand why we're doing all this math.
Yeah, exactly. You're probably a little bored. It feels like a math class, but
Yeah.
we've got to understand the math so that we can do cool stuff like that.
Yeah.
Okay.
All right, so let's find the percent composition of some of the substances that were in that reaction.
I think that's a very good idea,
All
Mr.
right.
Sam.
So
So, percent composition, what
Yeah.
is that?
That is the percentage of things by, whoops, sorry about that. Percentage of each element by mass in a compound.
So it's like a formula.
Yeah.
What you're going to do is you're going to take the mass
Of each element.
of one element,
Yeah, right.
and you're going to divide it by the molar mass of the compound.
Right.
Almost. There's one more thing you have to do, right?
Then times 100.
You'll take 100 times that. You might want to put the 100 over here. It might make more
doesn't
sense.
matter.
Okay, same thing. It's
All right.
pretty easy.
Yeah, it's easier
Okay.
if we just show you.
Yeah. Okay, let's just show you. I think we should do some examples.
All right.
So, the chemicals that you used yesterday, what were the two chemicals that you had?
Potassium permanganate.
Potassium permanganate.
Yep.
All right, potassium permanganate. I love that. Manganate.
It's so pretty too. It's purple.
It's purple.
Yeah.
Purple, pretty purple.
All right, so let's make the formula for that.
Okay,
so
potassium is K.
That's K plus, has +1 charge.
Why is it +1 charge?
Because it's in the first
Good.
column.
Okay, and permanganate's upon you haven't memorized probably,
It's on your sheet. Mn.
MnO4
the minus
negative
1
1.
charge.
Oh, -1 plus 1. The charges right here, they add up, so
Yep.
it's K
KMnO4.
MnO4. That's easy. So the first thing I would recommend that we do is find the molar mass of KMnO4.
Okay, let's do it.
So potassium, if we look in the periodic table, is 39. And there's just
39.
one of them, okay? Plus manganese is 52, 51?
55.
55. Ooh, I missed
Yeah.
one. 55. We're
Ah.
looking at the periodic table there. And then plus 4 times 16.
16.
I bet you've got oxygen memorized by this stage of the
Yeah.
game. And so we're going to add that up. And probably we should have our calculator to do this, shouldn't we? So maybe I
do
should
it.
turn the calculator on. Okay, let's do that. K,
Okay.
39.
39 plus.
Plus
55.
55.
Plus.
4
4
times 16 equals, or enter, and I get 158. 158 grams per mole.
All right.
So let's do potassium first.
Okay, so potassium is 39.
So I'll say 1 times 39 because there's one potassium over 158 times 100.
Okay.
That's easy, Mr.
Yeah.
Sam's. So,
So-
that'll be 39. I'm going to ignore the 1. That's
Yeah.
just kind of waste of time. Divided by
that you
158.
Hit times. You hit times.
Oh, I did. All right. 39 divided by 158 gives
Times
me.
100.
Yeah, actually, I don't like the times by 100, Mr. Sam's, because I'm smart enough to say that's 0.246. So I'm going to say 24.7%.
Wow. Pretty smart.
I'm pretty smart. You can say times 100 if you want, and of course that will give you the same answer. But
Yeah.
you know, if you whatever,
Okay.
either way.
All right.
And we usually do the other ones. Manganese.
Manganese.
That would be 55 over 158
Mm-hmm.
times 100. And so 55, I'll do it the regular way that most students will do it, divided by 158 times 100. And I get,
That's not right. You hit times again. You didn't divide.
I tell you, this computer, 55 times...
Nope. Divided by.
Divided by 1, is it late or what?
Good thing there's 2 of us here.
Times 100. Well, I looked at that number and said something's wrong.
There we go. That makes a lot more
I
sense.
can believe that that's 34%, 34.8%. And
Okay.
lastly, we would take the oxygen. Now, the oxygen is a little bit different because there's more than one
There's
oxygen.
4 times 16 there.
So it'd be 4 times 16 over 158 times 100. Not 1,000. Ah!
Times 100. There we go.
Oh, you
All right.
la
4 times 16.
4 times the 615.
Divided by.
Divided by 158.
158.
I'll
Times
do
100.
40.5%. All right, I know it's a decimal, but I'm smart. 40.5%, because I can move the decimal over 2 places right here, right?
Yep.
Okay.
Okay.
That's
so
it.
those are the percentages of each of those elements by mass in that compound.
Now, do we need to know that, Mr. Sands?
Let's do one more.
All right.
Let's
How
use
about-
the other component of our flaming fiasco yesterday.
I think that'd be a very good idea. And here the other ones are, Mr. Sams. What was the
Yes.
chemical, the other chemical
the other
of
one
yesterday?
was glycerin.
Glycerin. Now, glycerin's an interesting chemical. Yeah. Do you know that triathletes will drink glycerin?
That's just weird.
I know they do that because actually it helps absorb water. So, particularly if you're like in a very very hot race, and they actually in their diet they won't drink it like by the bottle, but they'll add it to their diet, and it helps water absorption. So you in a very hot you won't sweat as much. It kind of
Wow.
retains your water. Do you know that? All right, what's the
I just don't
formula
think
of
I'd
glycerin?
want to participate in something that I'm going to have to drink glycerin in order to succeed in
Some
this
people
said
swear.
event.
I've never done it. I've never done it, but people swear by it.
Yeah,
They
alright.
say you should try it. It does sometimes cause some gastrointestinal issues for some people.
Lovely.
Yeah.
All right, formula of glycerin. We'll just look this one up. C3H8O3. We didn't know off the top of our heads either. We had to look it.
All right. So,
All right, first
find
we
the
need to
molar
find
mass.
the molar mass. Yeah.
So the molar mass will be 3 times 12. Carbon weighs 12 plus 8. Hydrogen weighs 1. 8 times
Yep.
1. So I just don't ignore the 1 plus
Times
3
1. Oh, yeah, I see what you mean.
times
Yeah,
16.
Okay.
So let's clear the calculator out.
3 times 12.
3 times 12. That's 36. I can do that without a calculator. Times, right? Plus 8 plus 3 times 16. I'm not as good with the calculator on the computer.
That's right. We'll get there.
That's 92.
92.
So for the carbon, that'll be 3 times 12 over 92. For the hydrogen, I'll just do it in order. 8 over 92. And the oxygen will be
3 times 16.
3 times 16 over 92.
And we're going to multiply each of those by 100.
Tell you what, I'll do it that way. You might even want to do it this way. See how I kind of do one thing at a time, like that. And all right, so
All right, to the calculator.
3 times 12 divided by 92 times 100. 39.1%.
9.1%.
Probably sig figs. We should say 2 sig figs. But,
Yeah, yeah.
most of these really round actually to
Quite nicely.
8 divided by 92, and I won't say times 100 because I can see. Actually, that's 0.08. That's 8.7%. Because if you times that by 1,000,
100.
I meant. I've been like working with freshmen, and they're
8.7.
skewing my
Are they
brain.
frying your brain?
I tell you, well, I've been trying to teach them how to convert a little bit, and it's killing them.
Yeah.
That's all right. It's good for them.
Yep. Builds character.
That's right.
And math
We've been
skills.
converting kilometers to meters, and they're timesing everything by 1,000, and
Oh.
my brain cells are thinking
Going to
1,000.
1,000. Cool.
Yeah, 52.2% oxygen.
All right.
That's it, guys. This
All
is
right.
easy.
Yep. Easy stuff.